Imagine you are the city forester for a community with 50,000 trees. Last night, a powerful storm moved through the region. Wind gusts reached nearly 60 miles per hour. By morning, several large limbs have fallen. Public works crews are responding to blocked streets. Residents are calling City Hall. Local reporters are asking questions, and the mayor wants to know what happened. But here is the real challenge. You are not responsible for one tree. You are responsible for an entire forest growing inside a city. Welcome to the Urban Forest Professional Podcast. This series is designed to help arborists and urban forestry professionals understand how cities manage and care for urban forests. If you already work in arboriculture, you likely have strong knowledge about pruning, removals, tree biology, and safety practices. Those skills are essential, but urban forestry requires a broader perspective. Traditional arborists typically focus on individual trees. When someone hires an arborist, the questions are often straightforward. Is this tree healthy? Is it safe? Does it need pruning or removal? Urban foresters ask very different questions. Instead of focusing on a single tree, they look at the entire tree population across a city. They ask questions such as, how many trees exist across the municipality? What species make up the urban forest? Are younger trees being planted to replace aging ones? Are certain neighborhoods lacking canopy coverage? These questions require data, planning, and long-term thinking. Urban forests grow across streets, parks, school grounds, and residential neighborhoods. The decisions urban foresters make today may influence the city for decades. In fact, many urban forestry decisions consider time horizons of 50 to 100 years. History provides a powerful example of why this long-term perspective matters. In the early 20th century, many North American cities planted rows of American elm trees along their streets. These trees created beautiful green tunnels that shaded roads and sidewalks. But cities planted far too many of the same species. When Dutch elm disease spread across the continent, millions of elm trees died. Entire streets suddenly lost their canopy. Some communities lost more than 70% of their trees. This disaster changed how cities manage urban forests. Urban foresters realized that city forests must be diverse, resilient, and actively managed. Instead of planting only one species, cities now aim to maintain a wide variety of trees to reduce the risk of catastrophic loss. Urban forestry today combines science, planning, and community engagement. Urban foresters analyze tree populations, plan long-term canopy goals, coordinate planting programs, and work with city officials, developers, and residents. It is both an environmental profession and a public service. For the ISA-certified Urban Forest Professional exam, remember this key concept. Urban forestry focuses on population management, not just individual tree care. When answering exam questions, think about the entire urban forest system, diversity, canopy coverage, and long-term sustainability. Those concepts are central to modern urban forestry. Today we explored the shift from traditional arboriculture to urban forest management. Instead of caring for individual trees, urban foresters manage entire tree populations across a city. But cities do not protect and invest in trees simply because they look nice. They do it because trees provide measurable benefits that help cities function. In the next episode, we'll explore why urban forests are increasingly viewed as essential infrastructure for modern cities. When most people think about city infrastructure, they imagine things like roads, bridges, water pipes, and electrical lines. These systems allow cities to function. Roads move people and goods. Water systems deliver drinking water. Storm drains carry rainwater away from streets. But there is another type of infrastructure quietly working throughout cities every day. Trees. Urban forests are increasingly recognized as green infrastructure. Green infrastructure refers to natural systems that provide services similar to engineered systems. Instead of concrete pipes or steel structures, these systems rely on natural processes. Trees are one of the most powerful examples of green infrastructure in urban environments. One of the most important services trees provide is stormwater management. When rain falls on a city, much of it lands on hard surfaces such as rooftops, sidewalks, and parking lots. These surfaces prevent water from soaking into the soil. Instead, rainwater flows quickly into storm drains. During heavy storms, this runoff can overwhelm drainage systems and cause flooding. Trees help reduce this problem in several ways. Leaves intercept rainfall before it reaches the ground. Branches slow the movement of water through the canopy. Roots absorb water and improve soil infiltration. A single mature tree can intercept hundreds of gallons of rainfall each year. When thousands of trees are spread across a city, the cumulative effect becomes significant. Trees also help regulate temperature. Cities tend to be warmer than surrounding rural areas because buildings and pavement absorb heat from the sun during the day and release that heat slowly at night. This phenomenon is called the urban heat island effect. Trees provide cooling through two primary mechanisms. First, they provide shade. Shade reduces the amount of solar radiation reaching pavement and buildings. Second, trees cool the air through a process called evapotranspiration. Water evaporates from leaf surfaces, which removes heat from the surrounding air. Neighborhoods with mature trees can be several degrees cooler than areas with little vegetation. Trees also improve air quality. Leaves capture airborne particles such as dust and pollution. Trees also absorb gases like nitrogen dioxide, sulfur dioxide, and ozone. Over time, trees store carbon in their trunks, branches, and roots, helping reduce greenhouse gases in the atmosphere. Because these benefits can be measured, cities increasingly treat trees as valuable infrastructure assets. Urban foresters often use tools like the iTree software suite, developed by the U.S. Forest Service. iTree helps estimate the environmental and economic value of urban forests. For example, it can estimate how much money a city's trees save by reducing stormwater runoff or lowering energy costs through shade. When these values are calculated, the benefits of urban trees become very clear. A single mature tree may provide thousands of dollars in environmental services over its lifetime. Across an entire city, the value of the urban forest can reach millions or even billions of dollars. For the ISA Urban Forest Professional Exam, remember that ecosystem services are central to modern urban forestry. Urban forests are considered green infrastructure because they provide measurable environmental and economic benefits. Understanding these benefits helps cities justify investments in tree planting, maintenance, and protection. Today we explored why cities increasingly recognize urban forests as essential infrastructure. Trees manage stormwater, cool cities, improve air quality, and store carbon. But in order to manage these benefits effectively, urban foresters need a way to measure the size and health of the urban forest. In the next episode, we'll explore one of the most important measurements in urban forestry: Urban Tree Canopy. Imagine looking down at your city from an airplane. From above, you can clearly see roads, rooftops, parking lots, and buildings spread across the landscape. But mixed among those gray and brown surfaces is another layer. A layer of green. This layer is formed by the crowns of trees, and urban foresters call it Urban Tree Canopy. Urban Tree Canopy, often abbreviated as UTC, refers to the percentage of land area covered by tree leaves and branches when viewed from above. If a city has 30% canopy cover, that means about 30% of the ground surface is shaded by tree crowns. Urban Tree Canopy is one of the most important measurements used in urban forestry. Why? Because many of the environmental benefits provided by trees are directly related to the size of their canopy. Larger canopies provide more shade. They intercept more rainfall during storms. They store more carbon in their wood and roots, and they cool surrounding neighborhoods more effectively. A city with 10% canopy cover will experience very different environmental conditions compared to a city with 40% canopy. Higher canopy coverage generally means cooler streets, better air quality, and improved stormwater management. Because of these benefits, many cities set canopy goals as part of their urban forest management plans. A common goal is around 30% canopy coverage, although some communities aim for higher levels depending on climate, land use, and available space. However, canopy coverage is rarely distributed evenly across a city. In many communities, wealthier neighborhoods tend to have more mature trees and higher canopy coverage. Lower-income neighborhoods often have fewer trees and less shade. This difference can lead to significant variations in temperature and environmental quality. Studies have shown that neighborhoods with low canopy coverage can be several degrees hotter during summer months compared to nearby neighborhoods with abundant trees. Urban forestry programs increasingly focus on identifying these canopy gaps. By mapping canopy distribution across the city, urban foresters can prioritize planting efforts in areas where trees are needed most. Urban Tree Canopy therefore serves two important purposes. First, it provides a simple way to measure the size of an urban forest. Second, it helps guide planting and management decisions. But measuring canopy across an entire city requires specialized technology. Urban foresters often rely on aerial imagery, satellite photography, and LiDAR data to analyze tree canopy. These tools allow professionals to map trees across thousands of acres, quickly and accurately. Geographic Information Systems, or GIS, are then used to analyze and display this information. GIS maps allow urban foresters to see where canopy is high, where it is low, and where new trees could provide the greatest benefit. For the Urban Forest Professional Exam, remember this key concept. Urban Tree Canopy is one of the most widely used indicators of urban forest health and size. Exam questions often emphasize that canopy cover measures the percentage of land area shaded by tree crowns, not simply the number of trees in a city. A city may have thousands of small trees but still have low canopy if those trees have small crowns. Today we explore the concept of urban tree canopy, and why it is one of the most important measurements in urban forestry. Canopy coverage helps cities understand the size of their urban forest and identify neighborhoods that need more trees. But once canopy is measured, cities must also understand what types of trees make up that canopy. In the next episode, we'll explore how urban foresters measure canopy using aerial imagery, LiDAR, and geographic information systems. In the previous podcast, we introduced the concept of urban tree canopy, the layer of leaves and branches that covers a portion of the city when viewed from above. But measuring canopy across an entire city is not as simple as counting trees. Cities often cover hundreds or even thousands of acres. Manually measuring every tree would take an enormous amount of time and effort. Instead, urban foresters rely on modern technology to measure canopy accurately and efficiently. One of the most common methods is aerial imagery. High-resolution photographs taken from airplanes or satellites allow urban foresters to see the city from above. These images clearly show tree crowns, buildings, roads, and other land features. Using specialized software, analysts can identify the areas covered by tree canopy and calculate the percentage of land shaded by trees. Another increasingly important technology is LiDAR, which stands for Light Detection and Ranging. LiDAR systems use lasers mounted on aircraft to scan the landscape below. The system sends thousands of laser pulses toward the ground and measures how long it takes for the light to bounce back. These measurements allow computers to create detailed three-dimensional maps of the environment. With LiDAR data, urban foresters can identify tree height, canopy shape, and even the structure of vegetation layers. This information can be extremely useful for understanding the complexity of the urban forest. Once aerial imagery or LiDAR data has been collected, the information is analyzed using geographic information systems, commonly called GIS. GIS software allows urban foresters to map and analyze spatial data. For example, a GIS map might show areas of high canopy coverage in dark green and areas with little canopy in lighter colors. These maps can be layered with other information, such as population density, land use, or neighborhood boundaries. This allows city planners and urban foresters to identify areas where additional tree planting would provide the greatest benefit. For instance, a GIS analysis might reveal that neighborhoods with the lowest canopy cover also experience the highest summer temperatures. In response, a city might prioritize tree planting programs in those areas to reduce heat exposure. This type of analysis allows urban forestry programs to move from reactive tree care to strategic canopy management. Instead of simply planting trees wherever space is available, cities can plant trees where they will have the greatest environmental and social impact. In addition to canopy analysis, GIS systems are also used to manage tree inventories, track maintenance schedules, and plan long-term urban forest strategies. Technology has therefore become a central tool in modern urban forestry. For the ISA Urban Forest Professional Exam, remember that aerial imagery, LiDAR, and GIS are commonly used tools for measuring and analyzing urban tree canopy. Questions may focus on understanding the difference between these technologies. Aerial imagery provides visual canopy coverage. LiDAR provides three-dimensional structural data. GIS organizes and analyzes spatial information. Understanding how these technologies work together is important for modern urban forest management. Today we explored how cities measure urban tree canopy using aerial imagery, LiDAR, and GIS mapping technologies. These tools allow urban foresters to analyze tree coverage across entire cities and identify areas where additional trees are needed. But measuring canopy alone does not ensure a healthy urban forest. The types of trees that make up the canopy also matter. In the next episode, we'll explore why species diversity is critical for building resilient urban forests. Imagine walking down a city street lined with beautiful, mature trees. Every tree looks the same species, the same size, the same canopy shape. At first, this might seem ideal. Uniform trees create a consistent and attractive streetscape. But from an urban forestry perspective, this situation can be extremely risky. Urban forests made up of only a few species are vulnerable to catastrophic loss. History provides several powerful examples. In the early 20th century, many cities across North America planted large numbers of American elm trees along their streets. These trees formed beautiful arching canopies that shaded entire neighborhoods. But the lack of diversity created a major problem. When Dutch elm disease spread across the continent in the mid-1900s, millions of elm trees died. Entire streets that once had continuous shade suddenly lost their canopy. Some cities lost more than 70% of their urban trees. A similar situation occurred more recently with the spread of the emerald ash borer, an invasive insect that attacks ash trees. Communities that had planted large numbers of ash trees experienced widespread tree loss once the pest arrived. These events taught urban foresters an important lesson. Urban forests must be diverse in order to be resilient. One widely used guideline for maintaining diversity is called the 10-20-30 rule. This rule suggests that a city's tree population should include no more than 10% of a single species, no more than 20% of a single genus, no more than 30% of a single family. By spreading the tree population across many species and genera, cities reduce the risk that a single pest or disease will destroy large portions of the urban forest. Species diversity also provides other benefits. Different species tolerate different environmental conditions. Some trees are better adapted to drought. Others tolerate poor soil or air pollution more effectively. By planting a wide range of species, urban forests are better able to survive changing environmental conditions. Climate change makes diversity even more important. As temperatures increase and weather patterns shift, some species that once thrived in a region may struggle to survive. A diverse urban forest provides flexibility, allowing cities to gradually adapt to new environmental conditions. Urban foresters therefore carefully select tree species when designing planting programs. They consider factors such as climate tolerance, pest resistance, growth rate, mature size, and site conditions. The goal is to create a balanced, resilient urban forest capable of withstanding future challenges. Species diversity also contributes to visual variety and ecological complexity. Different species provide different habitats for birds, insects, and other wildlife. A diverse canopy supports a richer urban ecosystem. For the ISA Urban Forest Professional Exam, remember that species diversity is essential for reducing vulnerability to pests and disease. The October 20-30 rule is commonly referenced in urban forestry as a guideline for maintaining healthy diversity within a tree population. Exam questions often test the idea that monocultures increase the risk of catastrophic loss. Today we explored why species diversity is essential for building resilient urban forests. A diverse tree population helps cities reduce pest vulnerability, adapt to environmental change, and support healthier ecosystems. But diversity alone does not tell us whether enough trees are being planted in a city. Urban foresters also need a way to measure how fully planted the urban forest is. In the next episode, we'll explore the concept of stocking levels and how cities identify new opportunities for tree planting. Imagine walking through two different neighborhoods in the same city. In the first neighborhood, nearly every street has mature trees. Tree crowns stretch across the road, providing shade for sidewalks and homes. Parks and yards are filled with healthy trees. In the second neighborhood, the streets are mostly bare. There are few mature trees, little shade, and long stretches of sidewalk without any vegetation. Both neighborhoods exist within the same city, but the tree populations are very different. Urban foresters use the concept of stocking levels to understand these differences. Stocking levels describe how fully planted an urban forest is within a given area. In other words, stocking levels measure how many trees exist compared to how many trees could potentially be planted. A neighborhood with high stocking levels already has many trees occupying available planting spaces. A neighborhood with low stocking levels has many potential planting sites, but relatively few trees. Understanding stocking levels helps cities identify where planting efforts should be focused. For example, an urban forester might analyze a neighborhood and determine that there are hundreds of potential planting locations along streets, parks, and public spaces. If only a small number of trees currently exist in those locations, the area has low stocking levels and represents an opportunity for canopy expansion. Stocking levels are especially important in areas where canopy coverage is already low. By targeting neighborhoods with low stocking levels, cities can reduce canopy inequality and improve environmental conditions for residents. Urban foresters often identify planting opportunities by conducting site assessments. These assessments look for locations where trees can grow successfully. Common planting locations include street tree planting strips, parks and recreation areas, school campuses, public right-of-ways, vacant or underutilized land. However, identifying planting sites requires careful evaluation. Urban environments present many challenges for trees. Sidewalks, underground utilities, compacted soil, and limited rooting space can restrict where trees can be planted. Urban foresters must consider factors such as available soil volume, sunlight exposure, and conflicts with infrastructure. In some cases, creative solutions, such as structural soil systems or engineered planting spaces, may be used to support tree growth. Another important consideration is long-term canopy planning. Urban forests grow slowly, and it may take decades for newly planted trees to reach maturity. Because of this, urban foresters must think carefully about where trees are planted today. The goal is not simply to plant as many trees as possible. The goal is to plant trees in locations where they can grow successfully and contribute to the long-term health of the urban forest. Planting programs that focus on strategic locations can significantly increase canopy coverage over time. For the ISA Urban Forest Professional Exam, remember that stocking levels measure how fully planted an urban forest is compared to available planting space. Areas with low stocking levels represent opportunities for planting and canopy expansion. Exam questions may emphasize that identifying planting opportunities requires both site evaluation and long-term planning. Today we explored the concept of stocking levels and how urban foresters identify areas where new trees can be planted. Understanding planting opportunities helps cities expand canopy coverage and improve environmental conditions for residents. But before cities invest in large-scale planting programs, they need reliable information about the trees that already exist. In the next podcast, we'll explore one of the most important tools in urban forest management, the Urban Tree Inventory. Imagine trying to manage a forest without knowing how many trees exist. You would not know which species are most common. You would not know which trees are healthy or declining. And you would not know where maintenance or planting efforts are most needed. Urban foresters face this challenge when managing thousands or even hundreds of thousands of trees across a city. To manage this complex system effectively, cities rely on a tool called the Urban Tree Inventory. An urban tree inventory is a systematic record of the trees that exist within a defined area. Inventories may include street trees, park trees, or sometimes all public trees within a municipality. In some cases, inventories even include trees on private property to better understand the overall urban forest. Each tree recorded in an inventory typically includes several pieces of information. Common data collected includes tree species trunk diameter, usually measured as diameter at breast height or DBH, tree condition maintenance needs, location coordinates, planting site characteristics. This information allows urban foresters to understand the structure and health of the tree population. For example, an inventory might reveal that a city has a high percentage of one species. That could indicate a vulnerability to pests or disease. An inventory might also show that many trees are reaching maturity at the same time, suggesting the need for increased planting to maintain canopy in the future. Urban tree inventories are also extremely useful for maintenance planning. Cities with large tree populations must perform regular maintenance such as pruning, inspections, and removals. Inventory data allows urban forestry departments to schedule this work efficiently. Instead of responding only to complaints or emergencies, cities can develop planned maintenance cycles. For example, a city might adopt a 5-year pruning cycle for all street trees. Inventory records allow managers to track which trees have already been pruned and which trees still require maintenance. Inventories also help cities estimate budgets and staffing needs. By knowing the number of trees and their maintenance requirements, urban forestry departments can plan resources more effectively. Another important benefit of tree inventories is improved risk management. Trees occasionally fail due to storms, decay, or structural weakness. Inventory data allows arborists to identify trees that may require inspection or removal before they become hazardous. Technology has greatly improved the way tree inventories are collected. In the past, inventories were often recorded on paper forms and later entered into spreadsheets. Today, many cities use mobile data collection tools. Field crews carry tablets or smartphones equipped with specialized inventory software. As they move through the city, they record tree data and automatically capture location information using GPS. The data is then uploaded into a centralized database, where it can be analyzed and mapped. This technology allows urban foresters to maintain real-time records of their tree populations. For the ISA Urban Forest Professional exam, remember that tree inventories provide the data needed to manage urban forests effectively. Inventories support planning, maintenance scheduling, risk management, and species diversity analysis. Exam questions often emphasize that inventories allow cities to shift from reactive tree care to proactive management. Today we explored how urban tree inventories help cities understand and manage their tree populations. By collecting detailed information about each tree, urban foresters can make better decisions about maintenance, planting, and long-term planning. But inventories can take time to complete, especially in large cities. In the next podcast, we'll explore a faster method for assessing urban tree conditions across an entire community: the Windshield survey. Urban tree inventories provide detailed information about individual trees. But what if a city needs a quick overview of its entire urban forest? Conducting a full inventory can take months or even years, especially in large cities with hundreds of thousands of trees. Sometimes urban foresters need a faster way to understand the general condition of their tree population. This is where the Windshield survey becomes useful. A windshield survey is a rapid assessment method used to evaluate the general condition and characteristics of an urban forest across a large area. Instead of recording detailed information about every individual tree, urban foresters observe tree conditions while driving or walking through neighborhoods. The goal is to gather broad patterns and trends rather than precise measurements. During a windshield survey, an arborist or urban forester may evaluate factors such as overall canopy coverage, dominant tree species, general tree condition, presence of pests or disease, storm damage, planting opportunities. Because the survey is conducted quickly, it allows urban forestry staff to cover large portions of a city in a relatively short period of time. This approach is especially useful when cities are first developing an urban forestry program. A windshield survey can help identify major issues that require immediate attention. For example, a survey might reveal that certain neighborhoods have very low canopy coverage. Other areas might contain many aging trees that will soon require replacement. A windshield survey can also help identify the spread of pests or disease. If an invasive insect has recently been detected in the region, urban foresters may use windshield surveys to estimate how widely it has spread throughout the city. While windshield surveys provide valuable information, they do have limitations. Because the method is observational and rapid, the data collected is less detailed and less precise than a full tree inventory. Individual tree measurements are usually not recorded, and tree locations are not mapped with the same accuracy. For this reason, windshield surveys are often used as a preliminary assessment tool. They help urban foresters understand the general condition of the urban forest before investing in a more detailed inventory. In many cases, cities begin with a windshield survey to identify priorities and then follow up with a full tree inventory in targeted areas. The two methods therefore complement each other. Windshield surveys provide quick insights and broad patterns, while inventories provide detailed data for long-term management. Another advantage of windshield surveys is their relatively low cost. Because the surveys can be conducted quickly by trained staff, they require fewer resources than comprehensive inventories. This makes them particularly useful for smaller municipalities that may have limited budgets. For the ISA Urban Forest Professional Exam, remember that a windshield survey is a rapid assessment tool used to evaluate general urban forest conditions across large areas. It is useful for identifying broad patterns such as canopy coverage, species dominance, and potential planting opportunities. However, windshield surveys do not provide the detailed data that full tree inventories offer. Today we explored how windshield surveys provide a fast and efficient way to assess the general condition of an urban forest. While they cannot replace detailed tree inventories, they help urban foresters identify trends and priorities across large areas. But once cities begin collecting more detailed data about their trees, they need a way to organize and analyze that information. In the next podcast, we'll explore how Geographic Information Systems, or GIS, help urban foresters map and manage tree inventories across entire cities. As urban tree inventories grow larger, the amount of data collected can become enormous. A city may have tens of thousands, or even hundreds of thousands of trees recorded in its inventory. Each tree may have multiple pieces of information associated with it, including species, trunk diameter, condition, maintenance history, and geographic location. Managing this information would be extremely difficult without specialized tools. This is where Geographic Information Systems, commonly known as GIS, play a critical role. GIS is a technology used to collect, store, analyze, and display geographic data. In urban forestry, GIS allows cities to map the location of individual trees and analyze patterns across the entire urban forest. When field crews collect inventory data, they often record the GPS location of each tree. This location data is then stored within a GIS database. Once the trees are mapped, urban foresters can visualize the entire tree population across the city. Instead of viewing rows of numbers in a spreadsheet, they can see tree locations on a map. GIS maps allow urban forestry departments to answer important questions. For example, where are the largest concentrations of trees located? Which neighborhoods have the lowest canopy coverage? Where are specific species located? Which trees require pruning or inspection? By combining tree data with other geographic information, urban foresters can gain even deeper insights. For example, tree inventory maps can be layered with data showing neighborhood boundaries, land use patterns, population density temperature maps, stormwater drainage systems. This type of analysis helps urban foresters identify areas where trees could provide the greatest environmental benefits. For instance, GIS analysis might reveal neighborhoods that experience high summer temperatures and have very little canopy coverage. These areas may become priorities for tree planting programs. GIS can also support maintenance planning. Urban forestry departments can map trees that require pruning, inspection, or removal. Work crews can then plan efficient routes and schedule maintenance operations more effectively. Another advantage of GIS is its ability to support long-term planning. Urban foresters can analyze trends over time by comparing data from different years. For example, they may track how canopy coverage changes as new trees are planted, or as mature trees are lost. These insights help cities develop strategic plans to maintain and expand their urban forests. GIS technology also improves communication with the public. Many cities now provide online tree maps where residents can view the location and species of trees in their neighborhoods. These tools increase transparency and encourage community engagement with urban forestry programs. For the ISA Urban Forest Professional Exam, remember that GIS is used to map and analyze urban tree inventory data. GIS allows urban foresters to visualize tree locations, identify canopy gaps, plan maintenance operations, and support long-term management strategies. Exam questions may emphasize that GIS integrates tree data with other geographic information to support data-driven decision-making. Today we explored how geographic information systems help urban foresters manage large tree inventories and analyze patterns across cities. By mapping tree data, urban forestry programs can make better decisions about planting, maintenance, and long-term planning. But understanding the current tree population is only part of managing an urban forest. Urban foresters must also think about how the tree population will change over time. In the next podcast, we'll explore why age and size distribution are critical for maintaining a stable and sustainable urban forest. Imagine walking through a neighborhood where nearly every tree is large and mature. The canopy is impressive. Tall trees stretch across the street, providing shade for homes and sidewalks. The neighborhood feels cooler and greener. But from an urban forestry perspective, this situation may actually signal a future problem. If most of the trees in an area are the same age, they may also decline at roughly the same time. When large numbers of trees begin to die or require removal within a short period, the community can experience a sudden loss of canopy. Urban foresters try to prevent this situation by maintaining a balanced age and size distribution within the urban forest. Age and size distribution refers to the proportion of trees that exist in different growth stages. These stages typically include newly planted trees, young trees, medium-sized trees, mature trees. A healthy urban forest includes trees at all of these stages. Young trees represent the future canopy. Medium-sized trees are actively expanding canopy coverage. Mature trees provide the majority of environmental benefits. This balanced structure helps ensure that as older trees decline, younger trees are already growing to replace them. Urban foresters often analyze tree populations by measuring diameter at breast height, or DBH. DBH is measured at approximately 4.5 feet above the ground and provides a standard way to estimate tree size and age. Inventory data allows urban foresters to group trees into DBH categories and analyze the distribution of tree sizes across the city. For example, a city may discover that most of its trees fall within the largest diameter classes. This suggests that many trees were planted during the same period decades ago. Without new planting efforts, the city could experience a major canopy decline as these trees reach the end of their lifespan. On the other hand, a city with a balanced distribution will have trees spread across many diameter classes. This means the urban forest is continually renewing itself over time. Maintaining balanced age distribution requires ongoing planting programs. Cities must consistently plant new trees each year to replace those lost to storms, disease, construction, or natural decline. Urban foresters also monitor tree survival rates. Young trees require care during the early years after planting. Watering, mulching, and structural pruning help young trees develop strong structure and healthy root systems. These early investments greatly improve the chances that young trees will eventually become mature canopy trees. Another important factor is species selection. Some tree species grow quickly but have shorter lifespans. Others grow slowly but may live for many decades. A well-designed urban forest includes a mixture of species with different growth rates and lifespans. This diversity helps maintain canopy coverage over time. For the ISA Urban Forest Professional Exam, remember that balanced age and size distribution is essential for long-term urban forest sustainability. A population dominated by trees of the same age can lead to large canopy losses when those trees decline. Exam questions may emphasize the importance of ongoing planting programs and monitoring tree demographics. Today we explored why age and size distribution are critical for maintaining a stable urban forest. By maintaining a balanced mix of young, medium, and mature trees, cities can ensure that canopy benefits continue for future generations. But planting new trees is only the beginning of the process. Young trees require special care during the early years after planting. In the next podcast, we'll explore young tree establishment and early care, and why the first few years after planting are critical for long-term tree survival. Planting a tree is an exciting moment for any community. New trees represent future shade, improved air quality, and a greener city. But planting a tree is only the beginning of a much longer process. For urban foresters, the most critical period in a tree's life is often the first 3 to 5 years after planting. During this time, young trees must establish a healthy root system and adapt to the stresses of the urban environment. Unfortunately, many newly planted trees fail to survive this early period. Poor planting techniques, drought stress, soil compaction, and limited root space can all affect young tree survival. Because of these challenges, urban forestry programs place significant emphasis on proper planting and early care. Successful tree establishment begins with correct planting practices. The planting hole should generally be 2 to 3 times wider than the root ball, but no deeper than the root ball itself. Planting a tree too deeply can suffocate roots and prevent oxygen from reaching the root system. One of the most important factors to watch for is the root flare, the point where the trunk widens at the base and transitions into roots. The root flare should remain visible at the soil surface after planting. If it is buried too deeply, the tree may develop structural problems later in life. After planting, mulching is often applied around the base of the tree. Mulch helps conserve soil moisture, moderate soil temperature, and reduce competition from weeds or grass. However, mulch should be applied properly. A common mistake is the creation of mulch volcanoes, where mulch is piled up against the trunk of the tree. Excess mulch against the trunk can trap moisture and promote decay. Instead, mulch should be spread evenly around the tree in a shallow layer, typically 2 to 4 inches deep, while keeping the trunk area clear. Young trees also require regular watering during the establishment period. Urban soils often drain quickly or become compacted, making it difficult for roots to access sufficient moisture. Providing consistent watering during the first few growing seasons greatly improves survival rates. Urban forestry programs sometimes install watering bags or use scheduled watering programs to support newly planted trees. Another important practice during the early years is structural pruning. Structural pruning helps guide the tree towards strong branch architecture. This involves removing competing leaders, poorly attached branches, or branches that may create structural weaknesses later. Early pruning is generally minimal and focused on guiding the tree's structure rather than shaping its canopy. Investing in early care has long-term benefits. Trees that establish strong root systems and healthy branch structure are more likely to survive storms, resist disease, and grow into mature canopy trees. Because mature trees provide the majority of environmental benefits in an urban forest, ensuring that young trees survive and thrive is essential for long-term canopy sustainability. For the ISA Urban Forest Professional exam, remember that proper planting depth, visible root flare, mulching, and watering are key factors in successful tree establishment. Questions often emphasize that planting too deeply and improper mulching practices are common causes of early tree failure. Today we explored the importance of young tree establishment and early care. While planting new trees is essential for expanding urban canopy, proper planting techniques and early maintenance determine whether those trees will survive and grow. But even well-established trees face challenges in urban environments. In the next podcast, we'll explore urban tree stress and the environmental pressures that affect tree health in cities. Trees growing in forests experience very different conditions than trees growing in cities. In natural forests, trees grow in deep soils surrounded by other vegetation. The ground is covered with organic matter, rainfall can infiltrate the soil easily, and root systems have plenty of space to expand. Urban environments are much more difficult places for trees to grow. In cities, trees must survive in environments filled with pavement, compacted soils, underground utilities, and heavy human activity. These conditions create what urban foresters call urban tree stress. Urban tree stress refers to the environmental pressures that affect tree health and growth in developed areas. One of the most common sources of stress is soil compaction. When soil becomes compacted by construction equipment, foot traffic, or vehicles, the spaces between soil particles become smaller. These spaces normally hold air and water that tree roots depend on. Compacted soils limit oxygen availability and make it difficult for roots to grow. Without sufficient oxygen and water, tree roots cannot function properly. Another major challenge for urban trees is limited rooting space. In many urban planting sites, tree roots must compete with sidewalks, building foundations, and underground infrastructure. Tree pits or planting strips may provide only a small volume of soil for roots to expand. Because roots cannot grow freely, the tree may struggle to obtain enough water and nutrients. Urban trees also face heat stress. Buildings and pavement absorb large amounts of solar radiation during the day and release heat slowly at night. This creates warmer conditions than surrounding rural areas, a phenomenon known as the urban heat island effect. Higher temperatures increase water demand and place additional stress on trees. Air pollution can also affect urban tree health. Vehicle emissions and industrial activity release pollutants such as ozone, nitrogen oxides, and particulate matter. While trees can help remove some of these pollutants from the air, high pollution levels can also damage leaf tissue and reduce photosynthesis. Another challenge is mechanical damage. Urban trees are frequently exposed to damage from lawn equipment, vehicles, vandalism, and construction activity. Wounds caused by mechanical damage can create entry points for insects and disease. Urban foresters must therefore consider these stress factors when selecting tree species and designing planting sites. Certain tree species are better adapted to tolerate urban conditions such as poor soils, heat, and pollution. Selecting species that are well suited to the local environment improves survival rates. Urban forestry programs may also use techniques to improve growing conditions. For example, soil improvement practices, structural soil systems, and expanded planting areas can help provide more rooting space. Mulching and proper watering can also help reduce environmental stress. Understanding these environmental challenges is essential for building resilient urban forests. For the ISA Urban Forest Professional exam, remember that soil compaction, limited rooting space, heat stress, pollution, and mechanical damage are common sources of urban tree stress. Exam questions may emphasize that urban environments create conditions very different from natural forests, and trees must be selected and managed accordingly. Today we explored the environmental stresses that affect tree health in urban environments. Understanding these challenges helps urban foresters design planting programs that improve tree survival and long-term canopy growth. But one group of trees provides especially important benefits in cities: large, mature trees. In the next podcast, we'll explore why mature trees are the backbone of urban forest ecosystems. When cities invest in planting trees, the goal is not simply to add greenery to the landscape. The real goal is to develop large, mature trees that provide long-term environmental benefits. While young trees are important for the future of the urban forest, mature trees are the ones providing the majority of benefits today. Large trees intercept more rainfall, store more carbon, provide more shade, and support more wildlife than small trees. In fact, the environmental value of a mature tree can be many times greater than that of a newly planted tree. For example, a large mature tree may intercept hundreds of gallons of rainfall each year, helping reduce stormwater runoff and pressure on urban drainage systems. The broad canopy of a mature tree can shade buildings, sidewalks, and streets, reducing surface temperatures and lowering energy demand for air conditioning. Large trees also store significantly more carbon in their wood and roots than smaller trees. Because they have accumulated biomass over many decades, mature trees play an important role in carbon storage within urban ecosystems. Mature trees also provide habitat for wildlife. Birds, insects, and other organisms depend on large trees for nesting sites, food sources, and shelter. As trees grow older, they develop more complex structures such as cavities, large branches, and layered canopies that support biodiversity. Despite these benefits, mature trees can sometimes be overlooked in urban forestry programs. Many cities emphasize tree planting initiatives, which are highly visible and popular with the public. Planting events are positive community activities and often receive media attention. However, planting trees is only the beginning of the process. It can take 20 to 50 years for a newly planted tree to reach maturity and provide the full range of ecosystem services. This means that protecting existing mature trees is extremely important. When mature trees are removed, cities may lose decades of environmental benefits that cannot be replaced quickly. Urban foresters therefore focus not only on planting new trees, but also on protecting existing canopy. This includes monitoring tree health, preventing construction damage, and managing tree risk carefully. Urban foresters often evaluate mature trees through inspections that assess structural integrity, health, and potential hazards. In some cases, mature trees may require pruning or support systems to maintain stability. The goal is to extend the lifespan of these valuable trees whenever possible. Another important consideration is canopy continuity. If large numbers of mature trees are lost without replacement planting, canopy coverage may decline dramatically. Urban forestry programs aim to ensure that younger trees are growing and developing before mature trees reach the end of their lifespan. This approach helps maintain consistent canopy coverage across generations of trees. For the ISA Urban Forest Professional exam, remember that large mature trees provide the majority of ecosystem services in an urban forest. Protecting mature canopy is therefore a key strategy in urban forest management. Exam questions often emphasize that planting trees is important, but preserving existing mature trees provides immediate and significant benefits. Today we explored why mature trees are essential to the health and function of urban forests. These trees provide the majority of environmental benefits and represent decades of growth and ecological value. But even healthy trees can face threats from severe weather. In the next podcast, we'll explore how storms affect urban forests and how cities prepare for storm events. Storms are one of the most significant natural disturbances affecting urban forests. Strong winds, heavy rain, ice accumulation, and saturated soils can all place tremendous stress on trees. When storms occur, urban foresters must balance two priorities. They must protect public safety, while also preserving as much of the urban forest as possible. Understanding how storms affect trees is therefore an important part of urban forest management. One of the most common types of storm damage is branch failure. High winds place pressure on tree canopies, causing branches to bend or break. Branches that are poorly attached or weakened by decay are especially vulnerable. Another common problem is whole tree failure. This occurs when a tree uproots or the trunk breaks. Several factors can increase the likelihood of whole tree failure. Trees growing in compacted soils or shallow rooting environments may not develop strong root systems. Trees with structural defects, such as weak branch unions, trunk cracks, or internal decay, may also be more susceptible to storm damage. Soil conditions can also play a role. After heavy rainfall, soils may become saturated and lose their ability to anchor tree roots effectively. When strong winds occur during these conditions, trees may uproot more easily. Urban foresters therefore focus on proactive management to reduce storm damage risks. One important strategy is structural pruning. Structural pruning is performed primarily on young trees to guide the development of strong branch architecture. By encouraging well-spaced branches and removing competing leaders, arborists help trees develop stronger structures that are more resistant to storm damage later in life. Another strategy involves regular tree inspections. Arborists inspect trees to identify structural defects, decay, or other problems that may increase failure risk. If hazards are identified, corrective pruning, cabling, bracing, or removal may be recommended. Urban forestry programs also prioritize species diversity when planting trees. Different tree species respond differently to storm conditions. A diverse urban forest reduces the chance that a single storm event will cause widespread damage to one type of tree. Storm preparation is another key component of urban forestry programs. Many cities develop storm response plans that outline procedures for responding to tree damage. These plans often include coordination between urban forestry staff, public works departments, emergency responders, and utility companies. After storms occur, crews focus first on clearing blocked roads and removing hazardous trees that threaten public safety. Once emergency work is completed, arborists may assess damaged trees to determine whether they can be pruned and preserved or must be removed. Urban forestry programs also learn from storm events. By analyzing which trees failed and why, cities can improve future planting and maintenance strategies. For example, if certain species consistently fail during storms, urban foresters may reduce their use in future planting programs. For the ISA Urban Forest Professional Exam, remember that structural pruning, regular inspections, and species diversity are key strategies for reducing storm damage risk. Exam questions may emphasize the importance of proactive tree management rather than reacting only after storms occur. Today we explored how storms affect urban forests and how cities prepare for severe weather events. By managing tree structure, inspecting trees regularly, and planning ahead, urban foresters can reduce damage and improve forest resilience. But storms are not the only environmental challenge cities face. Urban areas also experience higher temperatures than surrounding landscapes. In the next podcast, we'll explore the urban heat island effect and how trees help cool cities. Cities are often warmer than the surrounding countryside. If you compare temperatures between a downtown area and nearby rural land, the city may be several degrees hotter, especially during summer evenings. This phenomenon is known as the urban heat island effect. Urban heat islands occur because cities contain large amounts of materials that absorb and store heat. Concrete, asphalt, brick, and roofing materials absorb solar radiation throughout the day. After the sun sets, these materials release the stored heat slowly into the surrounding air. This process keeps urban areas warmer, particularly at night. The lack of vegetation in many urban areas also contributes to this temperature difference. In natural landscapes, trees and other plants provide shade and cool the air through a process called evapotranspiration. When water evaporates from leaf surfaces, it absorbs heat from the surrounding environment, which lowers air temperatures. In cities with limited vegetation, this cooling effect is reduced. Urban heat islands can have significant impacts on human health and energy consumption. Higher temperatures increase the demand for air conditioning, which raises energy use and electricity costs. Heat waves can also create dangerous conditions for vulnerable populations, including older adults, young children, and people with certain health conditions. Urban trees play a major role in reducing these heat effects. One of the most obvious benefits of trees is shade. Tree canopies block sunlight from reaching buildings, sidewalks, and pavement. This reduces the amount of heat absorbed by these surfaces. Shaded pavement can be significantly cooler than pavement exposed to direct sunlight. Trees also cool the surrounding air through evapotranspiration. As water evaporates from leaves, heat energy is removed from the air. When large numbers of trees are present across a city, this cooling effect can significantly reduce local temperatures. Studies have shown that neighborhoods with abundant tree canopy may be several degrees cooler than nearby areas with little vegetation. Urban forestry programs, therefore, often prioritize tree planting in areas that experience the highest heat levels. These areas are sometimes called heat vulnerability zones. Planting trees in these locations can improve public health, reduce energy consumption, and increase overall comfort for residents. Urban planners may also combine tree planting with other strategies to reduce heat islands. These strategies can include reflective roofing materials, green roofs, and expanded green spaces. However, trees remain one of the most effective and cost-efficient tools for cooling cities. In addition to cooling benefits, trees planted in heat-vulnerable neighborhoods often provide multiple additional benefits. They improve air quality, reduce stormwater runoff, and enhance neighborhood aesthetics. For the ISA Urban Forest Professional Exam, remember that trees help reduce the urban heat island effect through shading and evapotranspiration. Exam questions often emphasize that neighborhoods with higher canopy coverage typically experience lower temperatures and improved environmental conditions. Today we explored how the urban heat island effect develops and how trees help cool cities. Urban forests provide one of the most effective natural solutions for reducing heat in densely developed areas. But cooling cities is only one of many environmental benefits that trees provide. In the next podcast, we'll begin exploring the concept of ecosystem services and how urban forests deliver measurable environmental and economic benefits to communities. When most people think about trees in cities, they often think about beauty. Trees make streets more attractive. They provide shade for parks and sidewalks. They help create pleasant neighborhoods. While these aesthetic benefits are important, urban foresters understand that trees provide much more than visual appeal. Urban forests deliver a wide range of measurable environmental benefits known as ecosystem services. Ecosystem services are the benefits that natural systems provide to human communities. In the case of urban forests, these services improve environmental conditions, support public health, and help cities function more efficiently. One of the most important ecosystem services provided by trees is air quality improvement. Urban areas often experience higher levels of air pollution due to vehicle traffic, industrial activity, and other sources. Tree leaves capture airborne particles such as dust and soot. They also absorb pollutants like ozone, nitrogen dioxide, and sulfur dioxide. While trees cannot eliminate air pollution entirely, they help reduce pollutant concentrations and improve air quality for residents. Another key ecosystem service is carbon storage and carbon sequestration. Trees absorb carbon dioxide from the atmosphere during photosynthesis and store carbon in their trunks, branches, and roots. This process helps reduce the concentration of greenhouse gases that contribute to climate change. As trees grow larger, they store increasing amounts of carbon in their biomass. Urban forests also provide significant stormwater management benefits. When rain falls on trees, leaves and branches intercept a portion of the rainfall. This slows the movement of water toward the ground and reduces the amount of runoff entering storm drains. Tree roots also improve soil structure, allowing more water to infiltrate into the ground. These processes help reduce flooding and decrease the burden on municipal stormwater systems. Urban forests also contribute to energy savings. Trees planted near buildings can shade walls and windows, reducing indoor temperatures during summer. This can lower the need for air conditioning and reduce electricity consumption. During winter, strategically placed trees can act as windbreaks, reducing heat loss from buildings. Another important ecosystem service involves improved human health and well-being. Research has shown that access to green spaces and tree-lined streets can reduce stress, encourage physical activity, and improve mental health. Trees also help reduce noise levels by absorbing and deflecting sound from traffic and other urban sources. Because these benefits can be measured, urban forestry professionals often assign economic values to ecosystem services. Tools such as the iTree software suite, developed by the U.S. Forest Service, allow cities to estimate the economic value of their urban forests. These tools can calculate how much money trees save through reduced energy use, improved air quality, and stormwater management. By quantifying these benefits, cities can better understand the value of investing in tree planting and maintenance programs. For the ISA Urban Forest Professional exam, remember that ecosystem services refer to the environmental and economic benefits provided by urban forests. Common examples include air pollution removal, carbon storage, stormwater management, temperature reduction, and energy savings. Understanding these benefits helps cities justify investments in urban forestry programs. Today we explored the concept of ecosystem services and how urban forests provide measurable benefits to communities. Trees improve air quality, store carbon, manage stormwater, reduce energy costs, and enhance public health. But one ecosystem service has become especially important as cities address climate change. In the next podcast, we'll explore carbon storage and climate mitigation in urban forests. One of the most important environmental challenges facing cities today is climate change. Rising global temperatures, changing weather patterns, and increasing extreme weather events are affecting communities around the world. Cities are responsible for a significant portion of global greenhouse gas emissions due to transportation, energy use, and industrial activity. Urban forests can play an important role in helping cities address this challenge. Trees absorb carbon dioxide from the atmosphere during a process called photosynthesis. During photosynthesis, trees use sunlight, water, and carbon dioxide to produce energy and grow. As trees grow, they store carbon in their wood, branches, leaves, and roots. This stored carbon remains locked inside the tree's structure for many years. This process is known as carbon sequestration. Urban forests contribute to climate mitigation in two primary ways. The first is carbon storage. Carbon storage refers to the total amount of carbon currently stored within the biomass of trees. Large mature trees store much more carbon than small trees because they have accumulated biomass over many years. The second contribution is carbon sequestration, which refers to the rate at which trees absorb carbon from the atmosphere each year. As trees grow larger, they continue to capture additional carbon dioxide and store it in their tissues. Urban forests therefore act as carbon sinks, helping reduce the amount of carbon dioxide in the atmosphere. However, the carbon benefits of urban forests depend heavily on long-term tree survival. If trees die prematurely or are removed before reaching maturity, much of the carbon stored within them may eventually return to the atmosphere through decomposition. This is one reason why protecting mature trees and maintaining healthy tree populations is so important. Urban forestry programs often track carbon storage as part of their sustainability initiatives. Using tools such as iTree, urban foresters can estimate how much carbon is stored in the city's tree population and how much additional carbon is captured each year. These estimates allow cities to include urban forests in climate action plans. In addition to directly storing carbon, trees also help reduce carbon emissions indirectly. For example, trees planted near buildings provide shade and reduce the need for air conditioning during hot weather. Lower energy use means fewer greenhouse gas emissions from power plants. Similarly, trees planted along streets and parking areas can reduce pavement temperatures, improving comfort for pedestrians and reducing urban heat island effects. Urban forests therefore provide both direct and indirect climate benefits. As cities develop climate adaptation strategies, many are expanding urban tree planting programs and prioritizing the protection of existing canopy. However, successful climate mitigation through urban forestry requires long-term commitment. Trees grow slowly, and the benefits of carbon storage increase over time. Urban forestry programs must therefore focus on both planting new trees and maintaining existing trees. For the ISA Urban Forest Professional Exam, remember that carbon storage refers to the total carbon stored in tree biomass, while carbon sequestration refers to the rate at which trees capture carbon from the atmosphere over time. Large, healthy trees store the most carbon and provide the greatest climate benefits. Today we explored how urban forests help cities address climate change by storing carbon and reducing greenhouse gas emissions. But climate mitigation is only one part of the environmental benefits provided by urban trees. Another important benefit involves managing rainfall and reducing flooding. In the next podcast, we'll explore stormwater management and how urban trees help control runoff in cities. When rain falls on a natural forest, most of the water soaks into the ground. Leaves intercept rainfall, roots absorb water, and the soil acts like a sponge, slowly releasing moisture over time. In cities, the situation is very different. Urban environments contain large areas of impervious surfaces such as roads, parking lots, rooftops, and sidewalks. These surfaces prevent water from infiltrating into the soil. Instead, rainfall flows quickly across the surface and enters storm drains. During heavy storms, this runoff can overwhelm drainage systems and lead to flooding. Stormwater runoff can also carry pollutants such as oil, chemicals, and debris into rivers and lakes. Urban forests help reduce these problems through several natural processes. One of the most important is rainfall interception. When rain falls onto tree canopies, a portion of that water is caught by leaves and branches. Some of this intercepted water evaporates back into the atmosphere before it ever reaches the ground. This process reduces the total amount of water entering the stormwater system. Trees also slow the movement of rainfall. Instead of hitting the ground all at once, rainwater drips gradually from leaves and branches. This slower movement allows more water to infiltrate into the soil. Tree roots play a major role in improving soil structure. Roots create small channels in the soil that allow water to move downward more easily. As roots grow and decay, they increase soil porosity and improve infiltration. Urban trees therefore help increase the amount of rainwater that soaks into the ground, rather than flowing across pavement. Another important factor is soil stabilization. Tree roots help hold soil in place, reducing erosion during heavy rainfall. This is especially important on slopes, stream banks, and other areas prone to soil movement. Urban forestry programs often integrate tree planting into broader stormwater management strategies. For example, cities may plant trees in areas designed to capture runoff, such as rain gardens, bioswales, or green infrastructure systems. These systems use vegetation and soil to filter and absorb stormwater before it reaches drainage systems. By combining trees with engineered solutions, cities can significantly reduce the volume of stormwater entering their infrastructure. Stormwater benefits can also be measured. Urban foresters often use tools like iTree to estimate how much rainfall is intercepted by the city's tree canopy each year. These estimates help demonstrate the economic value of urban forests. In some cases, the stormwater management benefits of trees can save cities millions of dollars in infrastructure costs. Instead of building larger drainage systems, cities can invest in tree planting and green infrastructure. For the ISA Urban Forest Professional Exam, remember that trees reduce stormwater runoff primarily through rainfall interception and improve soil infiltration. Exam questions often emphasize that tree canopies intercept rainfall and roots improve soil structure, allowing more water to infiltrate into the ground. Today we explored how urban trees help manage stormwater and reduce flooding in cities. Through rainfall interception, soil stabilization, and improved infiltration, trees act as a natural stormwater management system. But rainfall management is only one of the many environmental services provided by urban forests. In the next podcast, we'll explore how trees help improve urban air quality and reduce pollution. Air pollution is one of the most significant environmental health challenges in cities. Urban areas often experience higher levels of air pollution due to vehicle traffic, industrial activity, construction, and energy production. These pollutants can affect human health, contribute to respiratory problems, and reduce overall quality of life. Urban forests play an important role in improving air quality and helping cities reduce pollution. Trees improve air quality through several natural processes. One of the most important is particle capture. Airborne particles such as dust, smoke, and soot can settle on the surfaces of leaves and branches. The rough surfaces of leaves help trap these particles, preventing them from remaining suspended in the air. When rain falls, many of these captured particles are washed off the leaves and carried into the soil. Trees also help remove certain gaseous pollutants from the atmosphere. Through small openings in their leaves called stomata, trees absorb gases such as ozone, nitrogen dioxide, and sulfur dioxide. These gases are then processed within the tree during normal physiological processes. While trees cannot eliminate air pollution entirely, they can reduce pollutant concentrations in areas with significant canopy coverage. Another way trees improve air quality is by reducing temperatures. As discussed in earlier episodes, trees cool urban environments through shade and evapotranspiration. Lower temperatures can reduce the formation of certain pollutants, particularly ground-level ozone. Urban forests also help reduce pollution indirectly by lowering energy consumption. When trees shade buildings and reduce the need for air conditioning, power plants produce less electricity. This can lead to lower emissions from energy generation. Trees planted along streets can also improve air quality for pedestrians and cyclists by creating small barriers between traffic emissions and sidewalks. In addition to improving air quality, urban trees provide several related benefits that contribute to healthier urban environments. For example, trees can reduce noise pollution by absorbing and deflecting sound waves. They can also create psychological benefits by making urban environments feel calmer and more pleasant. Research has shown that people often experience reduced stress and improved mental well-being in areas with abundant trees and green spaces. Urban forestry programs sometimes use air quality models to estimate the pollution removal benefits of trees. Tools such as iTreeEco can estimate how much pollution is removed by urban forests each year. These estimates help cities quantify the environmental value of their tree populations. However, it is important to remember that not all tree species perform equally in terms of pollution removal. Trees with large leaf surfaces and dense canopies often capture more airborne particles than smaller or sparse trees. Urban foresters therefore consider species selection carefully when designing planting programs. For the ISA Urban Forest Professional Exam, remember that trees improve air quality by capturing airborne particles and absorbing gaseous pollutants through their leaves. Exam questions may also emphasize that urban trees indirectly improve air quality by reducing temperatures and lowering energy demand. Today we explored how urban trees contribute to improved air quality in cities. By capturing pollutants, reducing temperatures, and lowering energy use, urban forests help create healthier environments for residents. But the environmental benefits of urban forests extend beyond air and water. In the next podcast, we'll explore how urban trees support public health and human well-being in cities. Urban trees provide many environmental benefits, but their impact goes beyond air quality, stormwater management, and climate regulation. Urban forests also play an important role in human health and well-being. In recent decades, researchers have increasingly studied how access to trees and green spaces affects physical and mental health. These studies consistently show that people who live in neighborhoods with more trees often experience better health outcomes. One of the most direct ways trees affect public health is through temperature regulation. As discussed in earlier episodes, tree canopy reduces urban heat through shade and evapotranspiration. Lower temperatures can significantly reduce heat-related illnesses during hot weather. Heat waves are one of the leading weather-related causes of death in many countries. Neighborhoods with limited tree canopy often experience the highest temperatures, and therefore face greater health risks. By increasing canopy coverage in these areas, cities can reduce heat exposure and improve safety during extreme weather events. Trees also help improve air quality, which has direct health benefits. Cleaner air can reduce respiratory conditions, such as asthma and other lung diseases. For children and older adults, improvements in air quality can have especially meaningful health impacts. But the benefits of urban trees extend beyond physical health. Trees and green spaces also support mental health and emotional well-being. Numerous studies have shown that people who spend time in natural environments often experience reduced stress and improved mood. Green spaces can provide opportunities for relaxation, recreation, and social interaction. Even simply viewing trees from a window has been shown to provide psychological benefits. In hospital settings, patients with views of trees and green spaces have been observed to recover more quickly than patients without such views. Urban forests also encourage physical activity. Tree-lined streets and shaded parks make outdoor spaces more comfortable and inviting. People are more likely to walk, run, or cycle in environments that are pleasant and shaded. This increased activity supports cardiovascular health and overall fitness. Urban forestry programs therefore contribute to healthier communities in multiple ways. In addition to environmental benefits, trees help create neighborhoods where people feel comfortable spending time outdoors. Urban planners and public health professionals increasingly recognize that access to trees and green spaces is an important factor in community health. As a result, many cities now incorporate urban forestry into broader public health initiatives. Tree planting programs may prioritize neighborhoods with limited canopy coverage and higher heat exposure. This approach helps ensure that the health benefits of urban forests are shared more equitably across the community. For the ISA Urban Forest Professional Exam, remember that urban trees contribute to public health by reducing heat exposure, improving air quality, encouraging physical activity, and supporting mental well-being. Exam questions may emphasize the connection between canopy coverage and improved health outcomes in urban environments. Today we explored how urban forests contribute to healthier communities by improving environmental conditions and supporting human well-being. From reducing heat stress to encouraging outdoor activity, trees play a vital role in creating livable cities. But the benefits of urban forests are not always distributed evenly. In the next podcast, we'll explore the concept of environmental justice and canopy equity in urban forestry. Urban forests provide many important benefits to cities. Trees cool neighborhoods, improve air quality, manage stormwater, and support public health. But these benefits are not always shared equally across a community. In many cities, tree canopy is distributed unevenly between neighborhoods. Some areas have abundant mature trees and shaded streets. Other areas may have very little canopy and limited access to green space. This imbalance has led to growing attention around the concepts of environmental justice and canopy equity in urban forestry. Environmental justice focuses on ensuring that all communities have fair access to environmental benefits and protections. Historically, some neighborhoods, particularly those with lower incomes or marginalized populations, have received fewer investments in green infrastructure. These areas may have fewer parks, fewer trees, and higher levels of pollution. As a result, residents in these neighborhoods may experience higher temperatures, poorer air quality, and fewer opportunities for outdoor recreation. Urban forestry programs increasingly recognize that expanding tree canopy in these neighborhoods can help address these disparities. This approach is often referred to as canopy equity. Canopy equity aims to ensure that all neighborhoods have access to the environmental and social benefits provided by urban trees. Urban foresters use several tools to identify areas where canopy equity efforts are needed. One of the most important tools is canopy mapping. By using aerial imagery and GIS analysis, cities can measure canopy coverage across different neighborhoods. These maps often reveal large differences in tree canopy between areas. Urban foresters may also combine canopy maps with other types of data, such as income levels, population density, heat vulnerability, air pollution exposure. This type of analysis helps identify neighborhoods where additional trees could provide the greatest benefits. For example, areas with low canopy coverage and high summer temperatures may be prioritized for planting programs. However, planting trees alone is not always enough. Urban forestry programs must also consider long-term maintenance, community engagement, and site conditions. Trees must be planted in locations where they have sufficient soil volume, sunlight, and space to grow. Equally important is working with local residents. Successful canopy equity programs often involve community members in the planning and planting process. Residents may help identify preferred planting locations, participate in planting events, and assist with watering and early tree care. This community involvement helps ensure that new trees are welcomed and supported. Urban forestry programs that focus on canopy equity can produce multiple benefits. They improve environmental conditions, support public health, and strengthen community connections to local green spaces. For the ISA Urban Forest Professional Exam, remember that environmental justice in urban forestry focuses on equitable distribution of canopy and environmental benefits across communities. Exam questions may emphasize that canopy equity programs often prioritize neighborhoods with low canopy coverage and higher environmental risk factors. Today we explored how environmental justice and canopy equity influence urban forestry planning. By identifying canopy gaps and working with communities, cities can expand urban forests in ways that benefit all residents. But planting trees and improving canopy requires cooperation among many groups. In the next podcast, we'll explore the concept of urban forestry stakeholders and the people involved in managing city forests. Urban forests do not exist in isolation. Trees grow along streets, in parks, near homes, and alongside businesses. Because of this, Many different people and organizations are involved in decisions about urban trees. These groups are known as stakeholders. A stakeholder is any individual or organization that has an interest in or is affected by urban forestry decisions. Understanding stakeholders is an important part of urban forest management. Unlike natural forests that may be managed by a single agency, urban forests exist in complex social environments where many groups influence decision-making. One of the most important stakeholders in urban forestry is local government. City governments are often responsible for managing street trees, maintaining parks, and developing urban forestry policies. Municipal forestry departments, public works departments, and park services often work together to care for public trees. Another important group of stakeholders includes residents and property owners. Many trees in cities grow on private property. Even when trees grow on public land, they often affect nearby residents. Homeowners may care deeply about the trees near their homes. They may appreciate the shade and beauty trees provide, but they may also worry about potential hazards, falling leaves, or root damage to sidewalks. Urban foresters often work closely with residents to address concerns while maintaining healthy trees. Businesses and developers are also important stakeholders. Construction projects, building expansions, and infrastructure improvements can affect nearby trees. Urban foresters frequently work with developers during the planning process to protect existing trees or incorporate new planting into development projects. Utility companies are another key stakeholder group. Power lines and trees often share the same space along streets. Utility companies must maintain safe clearance between trees and electrical infrastructure to prevent outages and hazards. Urban forestry programs often coordinate closely with utilities to manage pruning and planting around power lines. Another important stakeholder group is community organizations and nonprofit groups. Many cities have volunteer tree planting programs or nonprofit organizations dedicated to expanding urban canopy. These groups often organize planting events, educate the public about tree care, and advocate for stronger urban forestry policies. Educational institutions, environmental groups, and neighborhood associations may also participate in urban forestry initiatives. Because so many stakeholders are involved, urban forestry professionals must develop strong communication and collaboration skills. Decisions about trees often involve balancing different interests and perspectives. For example, a resident may want a tree removed because it blocks sunlight, while the city may want to preserve the tree because of its environmental benefits. Urban foresters often act as facilitators, helping different groups understand the value of urban forests and work towards solutions that benefit the community. For the ISA Urban Forest Professional exam, remember that urban forestry involves many stakeholders, including municipal governments, residents, developers, utility companies, and community organizations. Exam questions may emphasize the importance of communication and collaboration when managing urban forests. Today we explored the many stakeholders involved in urban forestry and how their interests shape urban forest management. Because trees grow in shared spaces, successful urban forestry programs depend on cooperation among governments, communities, and organizations. But when different stakeholders have different priorities, conflicts can sometimes arise. In the next podcast, we'll explore conflict resolution and how urban foresters manage disagreements about trees. Urban trees provide many benefits to communities, but they can also become the source of disagreements. Because trees grow in shared spaces and affect many people, urban forestry professionals frequently encounter conflicts between stakeholders. For example, a resident may request that a tree be removed because it drops leaves or blocks sunlight. Another resident may strongly oppose removing the same tree because it provides shade and beauty. Developers may want to remove trees to make space for construction. Meanwhile, city officials may want to preserve those trees because of their environmental value. Urban foresters must often navigate these competing perspectives. Managing these situations effectively requires strong communication and conflict resolution skills. One of the first steps in resolving conflicts is listening carefully to stakeholder concerns. People often feel strongly about trees, especially those located near their homes. By listening respectfully and acknowledging concerns, urban foresters can build trust with community members. The next step is providing clear information. Many conflicts arise because people may not fully understand the role of urban trees or the policies that guide their management. Urban foresters can help resolve misunderstandings by explaining the benefits of trees, the reasons behind management decisions, and the potential consequences of different actions. For example, if a resident requests the removal of a healthy tree, the urban forester may explain the environmental benefits the tree provides, such as shade, stormwater management, and improved air quality. They may also explain the city's policies regarding tree preservation. Sometimes conflicts involve legitimate safety concerns. If a tree shows signs of structural instability or disease, removal may be the safest option. In these cases, urban foresters often conduct a tree risk assessment to evaluate the likelihood of failure and the potential consequences. Sharing the results of these assessments can help stakeholders understand why certain actions are recommended. Another important strategy in conflict resolution is seeking compromise solutions. For example, Instead of removing a tree entirely, pruning may address concerns about overhanging branches. In other situations, replacement planting may help balance the loss of a tree. Urban forestry professionals must also be familiar with local tree ordinances and policies. These regulations often guide decisions about tree removal, planting, and maintenance. By following established policies, urban foresters ensure that decisions are consistent and transparent. Maintaining fairness and consistency helps build trust with the community. Finally, public education plays an important role in preventing conflicts. When residents understand the value of urban trees and the goals of urban forestry programs, they are more likely to support management decisions. Community workshops, public meetings, and educational outreach can help strengthen these relationships. For the ISA Urban Forest Professional Exam, remember that effective communication, clear information, and understanding stakeholder concerns are key strategies for resolving urban forestry conflicts. Exam questions may emphasize the importance of balancing community concerns with urban forest management goals. Today we explored how urban forestry professionals address conflicts and work with communities to manage trees and shared spaces. By listening carefully, communicating clearly, and applying consistent policies, urban foresters can resolve disagreements and maintain public trust. But effective communication involves more than resolving conflicts. In the next podcast, we'll explore public outreach and education and how urban forestry programs engage communities to support urban forests. Urban forests thrive when communities understand and support them. While professional arborists and urban foresters manage many aspects of tree care, the long-term success of urban forestry programs often depends on public engagement. Public outreach and education help communities understand the value of trees and encourage residents to participate in caring for their local urban forest. Many people interact with urban trees every day. Trees line streets, shade sidewalks, and grow in parks and neighborhoods. However, many residents may not realize the important environmental services these trees provide. Public education helps explain how trees contribute to cleaner air, cooler temperatures, stormwater management, and improved public health. One common outreach strategy is community tree planting events. These events invite residents to help plant trees in parks, school grounds, or neighborhood streets. Planting events not only increase tree canopy, but they also strengthen community connections. When people participate in planting trees, they often develop a sense of ownership and responsibility for those trees. This can lead to improved tree care and higher survival rates for newly planted trees. Another important outreach tool is educational programming. Urban forestry departments and nonprofit organizations often provide workshops, presentations, or educational materials that teach residents about tree care. Topics may include proper watering techniques, mulching practices, and how to identify tree pests or diseases. Educational programs may also target schools. School-based tree programs help introduce students to the importance of trees and environmental stewardship. These programs encourage young people to develop an appreciation for urban forests and may inspire future careers in environmental fields. Many cities also provide online resources and interactive maps that allow residents to learn more about local trees. For example, some cities maintain online tree maps where residents can view the location, species, and size of trees in their neighborhood. These tools increase transparency and help residents feel more connected to the urban forest. Community partnerships are another important part of public outreach. Urban forestry programs often collaborate with nonprofit organizations, neighborhood associations, and environmental groups. These partnerships help expand the reach of educational efforts and support volunteer participation. Volunteers may assist with tree planting, watering young trees, conducting basic inventories, or helping monitor tree health. Public outreach also helps address common misunderstandings about trees. For example, some residents may worry about leaf litter, root damage, or maintenance costs. Educational efforts can help explain how proper tree selection and maintenance reduce these issues while still providing significant benefits. Ultimately, successful urban forestry programs recognize that community support is essential. Trees grow in shared spaces, and their care requires cooperation between governments, residents, and organizations. By building strong relationships with the public, urban foresters help ensure that urban forests are valued and protected. For the ISA Urban Forest Professional Exam, remember that public outreach and education are key components of successful urban forestry programs. Exam questions may emphasize that community involvement improves tree survival, encourages stewardship, and strengthens support for urban forest initiatives. Today we explored how public outreach and education help build community support for urban forests. By engaging residents, schools, and community organizations, urban forestry programs create stronger partnerships and encourage stewardship of local trees. But community engagement often depends on one powerful concept: the many ways trees benefit people and communities. In the next podcast, we'll explore how urban foresters communicate the value of ecosystem services to the public and decision makers. Urban forests provide many benefits to communities, but those benefits are not always immediately visible. City officials, residents, and decision-makers often have many competing priorities. Roads need repairs, schools require funding, and public safety services demand resources. In this environment, urban forestry programs must clearly communicate the value of trees. Urban foresters therefore spend a significant amount of time explaining the benefits of urban forests to policymakers, community leaders, and the public. One of the most effective ways to communicate the value of trees is by discussing ecosystem services. As we explored in earlier episodes, ecosystem services include benefits such as stormwater management, improved air quality, carbon storage, and reduced urban heat. When these services are described in measurable terms, it becomes easier for decision-makers to understand their importance. For example, a city may calculate how much rainfall its urban tree canopy intercepts each year. If trees intercept millions of gallons of stormwater annually, that represents a real infrastructure benefit. Instead of building larger drainage systems, the city can rely on natural systems to manage some of that water. Another important communication strategy involves economic valuation. Urban forestry professionals often translate ecosystem services into financial terms. For example, trees that shade buildings can reduce air conditioning costs during the summer. Lower energy use means lower electricity bills for residents and businesses. Stormwater interception can also reduce the cost of constructing and maintaining stormwater infrastructure. Tools such as iTree, developed by the U.S. Forest Service, help urban foresters estimate these economic values. Using these tools, cities can calculate the annual financial benefits provided by their urban forests. When policymakers see the economic value of these benefits, it becomes easier to justify funding for tree planting, maintenance, and preservation programs. Another effective communication approach involves visual examples. Maps, charts, and photographs can help demonstrate the impact of urban forests. For example, maps showing canopy coverage across neighborhoods can reveal areas with limited tree canopy and higher temperatures. These visual tools help illustrate why planting programs are needed. Urban foresters also use storytelling to communicate the importance of trees. Stories about how trees improve neighborhoods, reduce heat exposure, or create welcoming public spaces can help people connect emotionally with urban forestry initiatives. Public presentations, community meetings, and outreach campaigns often combine scientific data with personal stories to make the message more engaging. Communication with decision makers is especially important. City councils, planning commissions, and municipal administrators often determine funding levels and policy priorities. Urban foresters must clearly explain how urban forests contribute to public health, infrastructure resilience, and community well-being. Effective communication helps ensure that urban forestry programs receive the support they need. For the ISA Urban Forest Professional Exam, remember that communicating ecosystem services and economic value is a key strategy for gaining support for urban forestry programs. Exam questions may emphasize the use of data, economic valuation, and visual tools to explain the benefits of urban forests to decision-makers and the public. Today we explored how urban foresters communicate the value of urban forests to communities and policymakers. By translating ecosystem services into measurable environmental and economic benefits, urban forestry programs can build stronger support for tree management and planting initiatives. So far we have explored how urban forests are measured, managed, and supported by communities. In the next podcast, we will begin a new section of the series. We'll shift our focus to the arboricultural practices that support healthy urban trees, starting with the professional standards that guide modern tree care. You've been listening to the Arborist-podcast. Our goal is to grow our collective knowledge, one domain at a time. If you enjoyed the podcast, please like, share, and subscribe to help us keep this momentum. Until next time, let's keep growing this community together.